Alright, today we're going to be looking at Unit 11, dimensioning angles. First of all, angles are measured in units of degrees. There are 360 degrees in a circle. So, if I came down here and split this thing up, and most of you will recognize this as the X and Y axis, 0 degrees would be over here, 90 degrees, 180 degrees, 270, and then back to 360. That would complete a full circle. That's how we measure a circle in degrees. Alright. Of course, the little round symbol up here stands for degrees. Now, we sometimes need to split that degree up into smaller increments. And to do that, we actually take, if you think about it like time, we actually take and we put minutes in there. Well, how many minutes are in an hour? There's 60. Just like that, there's 60 minutes in a degree. 1 degree equals 60 minutes. Now, of course, that would be 1 degree equals 60, and a 1 tick mark means minute. Okay? Now, sometimes we want to take and actually split that thing up a little farther. We want to take minutes and split those up just like we do in time. We split minutes up into seconds. 1 minute equals 60 seconds. 2 little tick marks is seconds. So we have degrees, minutes, and seconds. Sometimes you'll see it on your calculator as DMS. Degrees, minutes, seconds. Which is the same as degrees, minutes, seconds. Alright. Now you're sitting here, well, I already knew all that stuff. Tell me something I didn't know. We're going to come back and look at some prints like what we use in fundamentals. This is the first print we give you. After you get done welding bandsaw blades, you get into doing your layout and stuff for your saw parts. This is the first print. There's 2 different types of angles on here. This one down here at the bottom, this one is what we call an included angle. That's the overall angle. How much does it measure overall? It measures 100 degrees. Now up here we have an angle going to the vertical center line. We call that angle to center line. Alright, now actually, do you know what the included angle of this top notch would be? If we added those two together, it would be 45 plus 45 would be 90 degrees included angle. Alright, so enough about that. Let's think about, well, how am I going to get this on my workpiece? How am I going to lay it out? This is the tricky part. This right here is a plate protractor, a square-headed protractor, you might hear it referred to as. But the thing is, when you look at your print, no matter what kind of tool you're using to put an angle on something, it doesn't automatically mean just because you see 100 degrees on here, you're going to set your instrument on 100 degrees. Because I'll show you an example. 100 degrees. Right here I'm seeing 90 right here on my plate protractor. If I go 100 degrees, that's just 10 degrees away from where I started at. That's nowhere near going to lay this part out right. What you have to do, you have to say, alright, what is the angle to center line of this? Well, the angle to center line would be 100 divided by 2, which would be 50 degrees. I want to hold my part. If I was going to come down here and lay this out, I'd hold this up, maybe along the bottom or whatever. I'm not going to do that because you can't read it very well. But we could actually turn this over. and say we were going to lay this out. I need to be, this right here needs to be in the same orientation as what I'm dimensioning off of. My center line. This is running the same direction as my center line. The bottom of my plate's running the same direction as the top of my part. I need to be 50 degrees away from that center line. All I have to do is go 10, 20, 30, 40, 50, and then lock it down. At that point, I can come down here and look, and you can see that I line up with my print right there. Okay, it lines up. I am actually taking and scribing a line 50 degrees from that vertical center line. Now, look what it says. 90 up here minus 50 is 40. 40 has nothing to do with 100. All we had to do is sit there and think about what's my dimension coming off of, and I need to go that many degrees away from it. That's on this print. The 45 degree up there at the top, we could actually take and use a combination square for that if we wanted to, because there's automatically going to be a 45 on this combination square. Or you could use this and do 45 degrees right there like that. Okay? Either way would work. Alright, that gets that print out of the way. The next print you get a drill gauge. Alright, we got a drill gauge. First of all, when I'm thinking about a drill bit, if I'm thinking about a drill bit, it's going to have a point on it. All of you should be, if you're in fundamentals, you're starting to sharpen drills right now. That drill has a point angle on it of an included angle of 118 degrees. The purpose of our drill gauge is to come in and be able to measure that point angle. Now, we'll talk about that 118 here in a minute. 31 degrees. 31 degrees. So, some people would say, well, I'm just going to set this right here. I'm going to set it on 31 degrees and I'll be good to go. That looks nothing like that angle does right there. So we're way off. First of all, what am I dimensioning off of? I'm dimensioning off of this vertical line here. I bring that up, get that orientated the same way, and we're going to go 31 degrees from that. So we go 90 minus 31. I can go 10, 20, 30, and then go one more, and it should be set right there on 59. So if I go 90 minus 31, be 59. Lock that down. Come up here and look. If you notice, it lines right up with my print. So I've got 90 minus 31 would be 59. Well, 59. What if I took 59 59 degrees. Guess what 59 times 2 is? It's 118. So there's why we've got that angle for our drill bits. On our drill gauge, we're measuring 59 degrees. That would be 118 included angle for a general purpose drill point. Alright, that's for the drill gauge. Then we get into a C-clamp. What I want you to look at on the C-clamp, we're going to talk about chamfers and bevels. Alright, chamfers and bevels. We're actually going to take and measure from there to there is a 1/2 inch, the horizontal distance. The vertical distance from there to there, because it's a 45 degree, would be a 1/2 inch in that direction and that direction. Any other angle you couldn't do that, but since it's a 45 degree, here's what you have. You've got a right triangle. You got a 90 there, a 45, and a 45. So the side opposite of 45 there is one length, and then the side opposite of 45 there is the same. So that'd be 1/2 inch and 1/2 inch. So that's how they're calling that out on the chamfer. Tolerance wise, plus or minus a 1/2 degree. When you look at most of your general tolerance blocks, let's look in our book right here real quick. Plus or minus a 1/2 degree. That's 30 minutes. Okay. You can also have a dimension that has a tolerance in it, and then you don't go to the standard tolerance block, and it explains to you here and shows you the high limit and the low limit. They're just taking plus 10 minutes and then minus 10 minutes, and you get 59.10 and 58.50. And implied degrees, you can read about that there, but that's just basically saying that every corner on that part is going to be implied 90 degrees. It doesn't have to be noted as a 90-degree angle.